All right, so we're going to talk about acids and bases in Unit 8. We're going to split it up into two parts. We're going to take the unit and you'll have two tests over it. It's a lot of material. Chapter 14 and 15 in our textbook. Note that in a lot of the notes we're using it's a chapter 16 from another textbook, but that's okay. Our textbook chapters are 14 and 15. The first test will include everything about pH and basic characteristics of acids and bases, strong acids and bases, weak acids and bases, equilibria, and titrations. And then the second part will include buffer, and that will be all new to you. Now, what we want to look at next first, though, is naming, because it's probably been a long time since you've seen this, and you will never be asked what is the name of this acid, but you will have to become familiar with the name so that you can write the reactions. Now, remember that acids begin with hydrogen. If I have a formula and it begins with hydrogen, I have an acid. If I have two elements, hydrogen and some other element from the periodic table, then you name it with hydro, then you put the stem of the other element, ic acid. So if your other element is chlorine, then that would be hydrochloric acid. If I have three elements, then I have a polyatomic more than likely. I look at the name of the anion or the polyatomic. If that ends in 8, then I take the stem of the anion again, ic acid. So I have nitrate, and that would be nitric acid. Again, if I have ite, however, so if I have nitrite or NO2, I take the stem of the anion again, and I add us. Ite goes with us, ate goes with ic. One way to remember this is to use the term I ate something and got sick, and then that will help you remember what goes with what. Now we've got a couple definitions of acids and bases, and so we're going to use these to talk about how acids and bases behave. So let's go to our packet. This is going to be 16.1. An acid is going to be a substance, right, that increases the concentration of hydrogen ion in water. And a base is going to be a substance that increases the concentration of hydroxide ions in water. So these are what we're most familiar with, right? Whenever we see hydroxide as the anion, we know that that's a base, and that's true here as well. So if I want to write just the reaction or the dissociation of an acid or an areneous acid or areneous base, they are in water, but water is not part of the chemical equation. It's just assumed to be there. And I write it with dissociating into the cation and the anion. For the base, my cation is sodium, and my anion is hydroxide. So that is the end of 16.1.